Welcome to Best Math and Science videos, Factoring by Grouping. Factoring a polynomial means writing it as the product of simpler expressions. For example, the expression 3x squared plus 17x plus 10 can be written as the product of 3x plus 2 and x plus 5. This is the factored form. If you multiply the parts, you get the original polynomial. You may already be familiar with methods of factoring trinomials, algebraic expressions like these with three terms. You use the coefficients and constants to determine the factors. As a review, check out the other Best Math and Science videos on factoring. I'll put a link to the videos below. These methods work for many trinomials, but what happens if the polynomial has four terms? How do you factor it then? Look at this example. How can you factor 2x cubed plus 12x squared plus 5x plus 30? When a polynomial has four terms, you can often factor it using a method called grouping. Group the first two terms and group the second two terms. You need to factor the greatest common factor from each of these. Look at the terms in the first group, 2x cubed and 12x squared. They have 2x squared in common, so factor that out to get 2x squared times x plus 6. And now look at the second group. The terms are 5x and 30. The common factor is 5, so factor that out to get 5 times x plus 6. Notice that the remaining parts are identical. Both are x plus 6. This means you can use the distributive property in reverse. You write the parts in common, in this case x plus 6, and then multiply it by the sum of the remaining parts, 2x squared plus 5. And this is the factored form of the expression. If you multiplied these terms, you would get the original expression. Let's review the steps you can follow to factor by grouping. Step 1 is to group the first two terms and the second two terms. Step 2 is to factor the greatest common factor out of each group. And step 3 is to use the distributive property in reverse to write the factored expression. And that's it. Let's look at other examples with important points you need to know. For example, how can you factor 6x cubed plus 21x squared plus 2x plus 7? The first step is to group the first two terms and group the second two terms. The second step is to factor out the greatest common factor from each group. In the first group, the greatest common factor of the numbers 6 and 21 is 3. And for the variables x cubed and x squared, the greatest common factor is x squared. So factor 3x squared from the first group. And now look at the second group. There are no common factors. When factoring by grouping, it's important to write 1 in front of the group that has no common factors. So this part is written as 1 times the remaining part, 2x plus 7. Notice now that the remaining parts are identical. Both are 2x plus 7. This shows that you can now use step 3. Use the distributive property in reverse by rewriting the parts in common, 2x plus 7, and multiplying it by the sum of the outside parts, 3x squared plus 1. And this is the factored form of the expression. Okay. Now, look at an example that shows a common error you need to avoid. How can you factor 2x cubed minus 6x squared minus 5x plus 15? The first step is to group the first two terms and group the second two terms. Here's a common error. Notice when grouping the second part that the subtraction applies to everything in parentheses. So you have to change plus 15 to negative 15. Be very careful to do this when grouping with a negative sign. So now the second step is to factor out the greatest common factor from each group. So factor 2x squared from the first group and factor 5 from the second group. Now notice that the remaining parts are both x minus 3. So multiply the parts in common, x minus 3, by the sum of the other parts, 2x squared minus 5. And this is the factored form of the expression. Here's another example. How can you factor 60x squared minus 4x minus 24 plus 10x cubed? This example shows some things you should always check before factoring. First, look at the order of the terms. It's important to start by making sure the expression is in standard form. This means ordering the terms from highest power to lowest power. So the expression should be written as 10x cubed plus 60x squared minus 4x minus 24. Now look at each of the numbers. A second thing you should always check is whether the terms have a common factor. How can you see what it is? Notice that all the terms are even. We can factor out a 2. So now the expression becomes 2 times 5x cubed plus 30x squared minus 2x minus 12. Now we can follow the normal steps for factoring. Group the first two terms and group the second two terms. Look at the second group. Notice the negative sign before the parentheses. When we grouped these terms, we had to change the sign of both terms inside the parentheses. So the negative sign before 12 is changed to a plus sign. Always be careful about the signs. Next, factor out the greatest common factor from each group. So factor 5x squared from the first group and factor 2 from the second group. The remaining parts are both x plus 6. So gather the outside parts, 2 times 5x squared minus 2, and multiply it by the parts in common, x plus 6. And this is the factored form of the original expression. Now consider this. How can you factor 4x cubed minus 7 plus 3x minus 4x squared? Remember to make sure the terms are in standard order, from the highest to the lowest power. This has the x squared term last, so we need to reorder it as 4x cubed minus 4x squared plus 3x minus 7. Okay, there's no common factors of all the terms. So we can now follow the steps for factoring. First group the first two terms and group the second two terms. Next, factor out the greatest common factor from each group. So factor 4x squared from the first group, and the second group has no common factor, so just write 1 before it. Now, look at the remaining terms in parentheses. They aren't the same. This means you cannot use grouping to factor this expression. Is there a way we could have known this before working through the problem? Yes. Let me show you how. Here are some examples we've looked at already. The first two can be factored using grouping, but the last one cannot. You can use ratios of the numbers of an expression to check whether it can be factored by grouping. Look at the first expression. Write a ratio of the first two numbers, in this case 6 over 21, and be sure it is in reduced form. So in this case, we can write it as 2/7. And write a ratio of the second two numbers. This is already in reduced form, 2/7. If the ratios are the same as they are here, the expression can be factored using grouping. Now, let's look at the numbers in the second expression. For the first two numbers, the ratio is 2/12, which reduces to 1 over 6. For the second two numbers, the ratio is 5 over 30, which also reduces to 1 over 6. Since the ratios are the same, this expression can also be factored using grouping, as we did before. But now look at the third expression. This method only works if the expression is in standard form, so we need to reorder this expression from the highest power to the lowest power. We need to switch the places of the squared term and the constant. Now the expression is in standard form, and we can check the ratios. The first two numbers have a ratio of 4 over -4, which reduces to -1. And the second two numbers have the ratio of -3 over 7. These ratios are not the same, so this expression can't be factored using grouping, which is what we found when we tried before. In this video, you've seen how to factor by grouping. You might also be interested in these related videos: factoring trinomials with a leading coefficient of 1, or with a leading coefficient not equal to 1, or using the difference of squares, or perfect square trinomials. Links to these videos are in the description below. And be sure to click below to subscribe to Best Math and Science videos. Thanks for watching. See you next time.